Okay. Number 10 is about rationalizing a rational expression. So, if you remember back in the olden days when you were in geometry and you had, say, well, I guess you didn't necessarily put it on the coordinate plane, but say you had a right triangle and you knew that this side was a length of 2 and this side was a length of 5. Yeah? And, just kidding. No, we're good. Okay. And then you were trying to find the hypotenuse C. Then you could let this be A, this be B, and that be C. And they use the Pythagorean theorem, a squared plus b squared equals c squared, right? So a squared would be 4, b squared would be 25, and c squared is what we're trying to find. So you would say 29 equals c squared, and since it's a physical thing, when I take the square root, we would just talk about the positive square root of 29. Okay? So then you could say, well, this is the square root of 29, and then if you were asked to determine the, like, say, sine of this angle. So I don't know if you guys remember, but sine is the opposite of our hypotenuse, so it would be 2 over the square root of 29. So 2 is the opposite of theta, and square root of 29 is the hypotenuse. Yeah? Well, that is an irrational expression, and you would have been expected to rewrite it so that you no longer had an irrational term in the denominator. So just to make it a little bit easier, let's go ahead and work with a smaller set of numbers. So what if I asked you to simplify or to rationalize 2 over the square root of 5, right? The idea is to no longer have an irrational term in the denominator, not necessarily in the whole thing. So here's what I know. If I multiply both the numerator and denominator by the square root of 5, well, technically I'm multiplying by 1, so I can do that. But the reason why we do this is because that's the square root of 5 squared, or the square root of 25, but however way you look at it. But that means my denominator would just become 5, because the operations cancel each other out, or because the square root of 25 is 5, however you want to see it. The numerator, remember, when we multiply fractions, would be straight across, so that would be 2 square roots of 5. So that would be the rational, uh, well, it's still irrational, but it would be the rationalized denominator. Yeah? Okay. So as far as, like, what does it mean to rationalize? It's remove the root from the denominator of a rational expression. Okay. I love how I put a period and didn't capitalize. Okay. So, if I have something a little bit more complicated, because it does say, give an example with a square root, what would you have to do to rationalize the expression with a cubed root? So, say I had 3 over the cubed root of, let's go with, we'll go with 2. Okay? If I explore that the same way that I did this one, I would multiply by the cubed root of 2 and multiply by the cubed root of 2. The only thing is I'm not done. And the reason why is because this right here is the cubed root of 2 squared. These two operations don't simplify each other out. The only thing that simplifies out a cubed root is a power of 3, the cubic, right? Which means I would need another set. And then I have the cubed root of 2 cubed, which would leave me with just a 2 in the denominator. Now, as far as the numerator goes, I would have a 3, and then the cubed root of 2 times the cubed root of 2 is the cubed root of 4. So if you were thinking ahead, then you could have said, well, I know I need 8 in the denominator. I need the cubed root of 8. So I just need to multiply by the cubed root of 4. That would be perfectly fine to write this as the cubed root of 4 instead of the cubed root of 2 twice. Okay? And so how do I rationalize with the cube root in the denominator? I would multiply by the cubed root in the numerator and denominator twice over, so that I would have the same power as the root. Okay, and that is, I think, all the problems.